Something was wrong with the ultraviolet readings. Not noisy, not inconsistent, wrong. Like the numbers were trying to describe a star lurking inside a comet. When the first graph printed in the control room at the Atmospheric Radiation Observatory in Colorado, the room went silent. Because every scientist who saw it understood the same thing instantly. 3I Atlas was emitting UV light that no comet should be capable of producing. And it was rising fast. By the next morning, the preliminary models were even worse. If the trend continued, if the emissions kept increasing at the rate the data implied, Earth's upper atmosphere would take the hit. Not a global apocalypse, not instantly, but the kind of damage that unfolds quietly, invisibly, until one day you walk outside and sunlight feels like a blade. Nobody wanted to say the number out loud. Not yet. But someone eventually did. 39%. That was the projected loss of ozone if 3I Atlas maintained its emission curve during perihelion. No natural object should be able to do that. And yet, the graph said otherwise. Stay with me, because by the end of this first part, you'll understand why one NASA physicist whispered a sentence no one should ever have to say. It's not just passing through the solar system. It's interacting with it. If you're watching this at night or early morning, buckle in. This is where the story begins to twist. The first anomaly arrived on December 4, 2025, at 2:11 a.m. local time. Dr. Marcus Hale wasn't supposed to be at the lab. He'd stayed late reviewing the new photometric series from the Maui telescope array, the one that finally confirmed the now famous 16.16-hour pulse cycle of 3I Atlas. He's been studying that object since its discovery, long before the public ever heard the word pulse. Even before the mainstream headlines turned it into a cosmic celebrity, Marcus already knew something felt off about it. Too regular, too stable, too deliberate. But nothing, not even those pulses, prepared him for the ultraviolet spike. He noticed it by accident, a small upward tick in the UVB flux inside the comet's coma. At first he assumed it was a detector glitch. The HelioWatch satellite had been having calibration issues for months. So he cross-checked with NOAA spectrographs. The bump was there too. Then he checked ESA's polarimetric spectrometer. Same thing. 3 independent systems, same rising slope. He zoomed into the curve, watching the line twitch upward like a heartbeat accelerating under stress. His first thought was, no, this is impossible. His second thought, if this is real, we're in trouble. He didn't go home, didn't sleep. He stayed in that chair until the room brightened with sunrise and the others walked in one by one with coffee cups and weary eyes, the graveyard shift scientists who'd read too many papers about 3I Atlas and still thought the public was being shielded from something. When Marcus explained what he'd found, nobody laughed. Nobody said glitch. They just looked at each other and understood the stakes. Comets do not emit UV radiation at destructive levels, but 3I Atlas wasn't behaving like a comet. Still, nobody panicked. Scientists don't panic, they model. And within 36 hours, they had their first model of what would happen to Earth's atmosphere if the UV output continued to climb. The result? A projected 39% depletion of the ozone layer over the course of 3 months beginning this spring. And that was the most optimistic scenario. At 5:32 p.m., the phone call came from Langley. Not NASA's PR office, the people who call when findings cannot leave the building. They wanted raw data, instrument logs, calibration files, access to atmospheric chemistry simulations. No mention of a public statement. No mention of next steps. Just send everything. Marcus hung up and stared at the receiver for a moment too long. He hadn't heard fear in their voices, but he'd heard something close. Urgency without explanation. The tone agencies use when they've already briefed someone above them, someone important. 2 hours later, another anomaly appeared, this time from the MAVRIC probes monitoring UV distribution at high altitudes over the Pacific. The intensity spike wasn't uniform. It wasn't diffusing in a natural pattern. It was pulsing, the same rhythm as 3I Atlas's brightness pulse, 16.16 hours. That was the moment the room changed. Like oxygen thinned, like gravity thickened. Because natural processes don't sync across millions of kilometers with that level of precision. A planetary atmosphere shouldn't respond like an echo chamber to something passing near Jupiter. Marcus felt the shift before anyone spoke it out loud. This wasn't an observational curiosity anymore. This was influence. Causal, measurable, escalating. Something out there, something half the size of a suburban town, was reaching across space and touching Earth's atmosphere with ultraviolet fingers. When the UV index in the models breached the hazardous threshold for mid-latitudes, Chicago, Denver, Boston, the room fell into a heavy, absolute quiet. That night, the senior team convened an emergency call with the Atmospheric Sciences Task Group in Washington. The call lasted 4 hours. When it ended, nobody knew what the official plan was, but one thing was clear. 3I Atlas wasn't just a visitor, it was a variable. And Earth had become part of its equation. Before I take you deeper into what happened next, the miscalculation, the leak, the retraction, the second leak that proved the first leak wasn't actually wrong, let me slow down. Because you need to understand how something as small as 3I Atlas can affect something as massive as Earth's atmosphere. And why, despite decades of studying comets, asteroids, and interstellar objects, nothing in the record books looks remotely like this. Ultraviolet radiation doesn't just appear from nowhere. Comets emit some UV due to photodissociation, sunlight breaking apart molecules like water, methane, carbon monoxide. But those emissions are weak, chaotic, diffuse. 3I Atlas was different. Its UV signatures were coherent, narrow-band, concentrated, as if produced by a stable mechanism rather than random ice sublimation. NASA models showed the emissions spiking at the peak of each 16-hour cycle, then falling sharply, then rising again with the next pulse, like a cosmic engine exhaling radiation instead of gas. But here's the real problem. UVC radiation, the kind nature filters out completely, the kind that shreds DNA like paper in a shredder. 3I Atlas was emitting a detectable amount of UVC. Not much, not enough to reach Earth yet, but enough to show up in high-altitude sensors. And UVC doesn't travel far in space unless it's produced with serious intensity. The fact we could detect it at all meant something alarming. The object was producing it deliberately. Not consciously, not intelligently, but mechanically, in the sense that a process, thermal, structural, chemical, or something unknown, was creating those emissions on a consistent cycle. When Dr. Leela Morrison, an atmospheric chemist from UC Berkeley, ran the depletion forecast with UVC included, the projected ozone loss jumped from 39% to 52%. Catastrophic. The kind of damage Earth hasn't seen in millions of years. The kind of damage that rewrites ecosystems, destroys crops, makes skin cancer rates jump tenfold, and turns clear skies into biological minefields. Leela printed the results and walked them across the room to Marcus. He read the percentage, then reread, then looked at her like she'd handed him a death certificate. "Run it again," he said. "I did," she whispered. By midnight, Langley had called 3 more times. So had NOAA. So had the Office of the Science Advisor to the President. Someone at Johns Hopkins tried to leak the severity of the model on Twitter. The tweet vanished within minutes, replaced with a sanitized explanation about transient UV signatures consistent with typical comet activity. Nobody in the room bought it. Nobody outside the room even knew what had been erased. But inside the lab, something worse happened. Much worse. At 12:44 a.m., an updated orbital simulation arrived from the Pasadena team. One line in the file summary froze Marcus mid-keystroke. Predicted UV flux amplification at perihelion, plus 230%. He opened the full model. His breath caught. He wasn't the only one who saw it.
A murmur spread across the room. Comets brighten as they heat up. Everyone knows that. But amplification of ultraviolet emissions by 230% wasn't warming. It was escalation. Like whatever was happening inside 3I-ATLS wasn't just stable, it was feeding on proximity to the sun. "That's not sublimation," someone whispered, but no one corrected them, because they were right. Around 3 a.m., Marcus stepped into the hallway outside the lab to breathe. He leaned against the wall, closed his eyes, and tried to imagine explaining this to the public. We think an interstellar object is emitting harmful ultraviolet radiation at increasing levels, synchronized with a precise internal cycle and projected to deplete the ozone layer by nearly 40%. It sounded fictional, like a plot meant to scare a Netflix audience. But the numbers were real. He stared at the floor tiles, the pale reflections of ceiling lights stretching across them, and remembered something Avi Loeb once said in a lecture at Harvard. If we refuse to believe data because it doesn't fit our expectations, then we are not doing science, we are doing faith. Right now, every expectation about comets was being shattered, but the data stayed firm. Robert Chen, a postdoc out of Stanford, joined Marcus in the hallway. He carried 2 coffees, handed one over, leaned against the opposite wall. "You think this is real?" he asked. Marcus didn't answer right away. Robert continued, "I mean, comets aren't supposed to do this. Nothing is supposed to do this." Marcus finally said, "Real doesn't mean familiar. It just means we haven't found a reason to dismiss it yet." Robert took a long, slow breath. "You think they're going to tell the public?" Marcus shook his head. "Not until they're forced to." A silence passed between them. Heavy, uncomfortable. Then Robert said something that would matter much later. "What if it's not just emissions? What if it's preparing for something?" Marcus didn't respond. He couldn't, because for a moment, just a moment, he let the thought exist. Then the hallway door swung open, flooding them with cold blue screen light. Layla stood there, gripping the door frame. "You need to come back," she said. "There's something new." Her voice didn't sound scared. It sounded shaken. Back in the lab, the room was pulled tight like a wire. Screens flickered with updated spectroscopic readings. One large display showed a new graph, something nobody expected: UV polarization. A pattern in the ultraviolet light emitted by 3I-ATLS had shifted, not randomly, not chaotically, but in a directional way, like the light was favoring a specific vector, toward the sun. No, not just toward the sun, toward Earth's orbital plane. Marcus approached the screen slowly. The polarization angles rotated in sync with the 16.16-hour pulse, but the intensity distribution was drifting, frame by frame, aligning more and more with the plane of Earth's orbit. Layla explained before he could ask. "It's not pointing at Earth," she said. "Not exactly, but it's adjusting. The emissions are narrowing. It's like a beam tightening its focus." Robert whispered, "Comets don't focus radiation." No one disagreed, because that wasn't the shocking part. The shocking part was how gradual the drift was. 36 hours earlier, the emissions had been uniform. Now they were anisotropic, uneven, and trending toward a directional bias, as if the object was targeting something. Marcus forced his mind back to science. "It has to be thermal," he said. "Some part of the nucleus is rotating into a hotter region, and—" "It's not thermal," Layla cut in. "Look." She brought up the infrared overlay. The heat signature of 3I-ATLS hadn't changed at all. If anything, it was slightly cooler. "So what's causing the polarization shift?" someone asked. No one answered, because there was no known natural mechanism for this. None. 3 people in the room exchanged glances that lasted too long. Not suspicion, not paranoia, recognition. Someone else must have seen the same pattern. Someone higher up. Someone already running their own models. It explained the urgent calls, the sudden data requests, the silence. The government wasn't confused. They were preparing. At 5:17 a.m., the Habitat Monitoring Unit at NASA's Goddard Center issued an encrypted bulletin to all participating research teams. Do not disseminate UV fluctuation data externally until interagency review is complete. Marcus stared at the message and felt something in him tighten. This wasn't a review. This was containment. He typed a response he knew he shouldn't. What scenario are we preparing for? He hit send before he could talk himself out of it. 30 seconds later, his inbox pinged with a one-line reply. Stand by for guidance. That meant nothing and everything. At sunrise, the team gathered to review the latest readings. Sleep-deprived, strained, eyes red, hands shaking slightly when they held coffee cups. The room smelled like stale air and fear. Marcus stood at the front, staring at the largest screen, the pulse graph. The UV peak had risen again. Not a small rise, not a deviation, a jump. 6% in one cycle. And the next cycle, another 6, then 8. The upward curve wasn't linear anymore. It was exponential. A soft sound escaped someone's throat, a gasp disguised as a cough. This isn't heating, Marcus said, voice hoarse. This is amplification. From what? Robert asked. No one knew. Or maybe no one wanted to answer. Leela stuck closer to the screen, narrowing her eyes. It's too fast. Way too fast. Even if it were a natural runaway process, it wouldn't be this coherent. The pulsation sharpened on the graph, each UV burst more defined, more energetic. Marcus felt his pulse start to sync with it, or maybe the graph was forcing the sensation on him, the way a metronome can make your heartbeat jump. We need updated projections, he said quietly. Run it with the exponential factor. Leela hesitated, not because she doubted the math, but because she feared the result. Still, she typed, hit enter, and the new projection loaded. The room inhaled as one. 62% ozone loss. In the next 5 months. Global radiation levels doubling. Unchecked. Unstoppable. A level of UV exposure no human civilization has ever survived. Robert stepped backwards, like the screen had pushed him. Someone else cursed under their breath. Another person whispered a prayer. Marcus didn't move, because he knew what came next. He'd known it since the first spike. 3I Atlas wasn't just dangerous. It was accelerating. Something inside it, something no comet carries, was growing stronger. And whatever the pulse was fueling, whatever the inner mechanism was doing, it was now interacting with our sun, our orbit, and our atmosphere. This changes everything, Marcus said. Leela met his eyes. No, she said, quietly. This ends everything. The room fell silent. Not shocked silence, understanding silence. Because once the ozone goes, there is no switch to flip it back on. It's not a system humans can repair. It's a shield Earth built over billions of years, and once shattered, sunlight becomes a weapon. Marcus felt the weight settle in his chest. The future was different now. Every prediction, every model, every hope changed. Then the phone rang. A landline. The one in the lab that never rang. The one reserved only for calls that mattered more than careers. Marcus picked up the receiver. A voice he didn't recognize said one sentence. Dr. Hale, step outside. We need to brief you privately. He set the receiver down slowly. His hand trembled. He didn't try to hide it. Everyone watched him walk toward the door. Leela called his name once, softly. He didn't look back. He stepped into the hallway. The door closed behind him. The room waited. 30 seconds passed. 60. 90. Then faintly through the small square window in the lab door, the team saw Marcus stop walking. His shoulders dropped. His hand lifted to his forehead. He stood frozen. Whatever he had just been told, it wasn't guidance, it wasn't reassurance, it wasn't a plan. It was something worse. When he finally turned back toward the door, his face was pale, his eyes unfocused. He opened the door slowly. Everyone looked at him. Marcus swallowed hard. They ran a new simulation, a classified one. Leela stepped forward.
What did it show? For a moment, he didn't answer. Then, with a voice barely above a whisper, "It's already too late." When Marcus said, "It's already too late," nobody in the room moved. Nobody breathed. It felt like the air thickened, like someone had tilted the world slightly off-center, and everyone was waiting to see if it would fall. Layla was the first to speak. "Too late for what?" Marcus didn't look at her. He stared at the floor as if the answer were written in the tile grout. "The ozone projection. It wasn't the worst-case scenario," he said. "It was the middle one." A silence, sharp as glass, slit through the room. "What's the worst case?" Robert asked. Marcus lifted his eyes. There was something broken sitting behind him. Not panic, not shock, acceptance. "Collapse," he said. And then more quietly, "Total hemispheric collapse." The words didn't register at first. Collapse of what? Atmospheric circulation? Temperature systems? Radiation shielding? Then the meaning clicked. The ozone layer, the entire protective blanket over 1/2 of the Earth, gone. Not reduced, not weakened, erased. No one reacted dramatically. There was no shouting, no crying, no pacing, just a collective stillness, the way people go quiet at funerals, trying to understand what death means when it comes too soon. Finally, Layla asked the only logical question. "What did the simulation show?" Marcus exhaled like the air hurt leaving his lungs. "That the emissions aren't the cause," he said. "They're the warning." The room erupted, not in noise, but in movement. People pushed chairs aside, grabbed tablets, screens bloomed with graphs and projections. The shift was immediate. Panic into analysis, fear into action. Marcus walked to the front display, his voice steady, professional, the voice of someone who knows there's no comfort left to offer, only clarity. The classified simulation wasn't about UV intensity, he said. It was about resonance. Resonance with what? Someone asked. With Earth's upper atmospheric chemistry, specifically ozone formation and destruction cycles. Layla frowned. How can an interstellar object resonate with a chemical cycle? That's what terrifies them, Marcus said, because no natural object should. He tapped the touchscreen. A diagram appeared, a sinusoidal graph overlaid with atmospheric HOX and NOx reaction loops. The 116.16-hour pulse, he said. It lines up with Earth's diurnal ozone regeneration cycle. That's impossible, Robert whispered. Marcus nodded. Yet it's happening. He zoomed in. The graphs were nearly superimposed. A pulse from millions of miles away, syncing with a chemical process that takes place dozens of miles above Earth's surface. How tight is the correlation? Layla asked. Within statistical noise. A murmur ran through the room. No one wanted to be the first to say what they were all thinking. This wasn't random. This wasn't coincidence. This wasn't how nature behaves. Not at this scale. Not at this precision. Before anyone could speak, the lights flickered. Once. Twice. Then the backup generators kicked in with a soft hum. A power outage? Here? On a clear morning? At a secured research facility? That never happened. Everyone froze. Then every phone in the room lit up at once. Emergency alerts from the atmospheric radiation network. Marcus grabbed his.
One sentence blinked on the screen. Significant UV anomaly over South Pacific. Satellite telemetry lost. For the first time in hours, genuine fear surged through the room. Telemetry lost. Not corrupted, not degraded. Lost. Satellites don't just go dark, not all at once. Which satellites? Layla asked, already knowing she didn't want the answer. All of them monitoring UV flux south of 30 degrees latitude, Marcus said. That's 12 platforms, someone whispered. 12. The room went quiet again. 12 satellites failing within seconds of each other meant one thing. A spike. A massive one. Sudden enough to blind multiple instruments simultaneously. Robert hurried to a terminal and pulled up ground-based UV sensors. The data was still coming in, the southern hemisphere readings, climbing. My God, he breathed. The UV index in the mid-stratosphere just doubled. Layla stepped behind him. That can't be real. It is, Robert said. Look at the timestamp. It happened right at the pulse peak. The 116.16-hour pulse. It's not just syncing with atmospheric chemistry anymore. It's driving it. Marcus felt something cold settle in his stomach. He said, They told me the reason the simulation predicted it was too late is because the effect isn't linear. It's not even exponential. It's cascading. The word hung in the air like smoke. Cascade. A runaway chain of reactions, self-sustaining, self-amplifying, irreversible. Explain, Layla said, though she already knew. Once ozone loss reaches a certain threshold, Earth's atmosphere becomes transparent to wavelengths that normally never reach the surface. Those wavelengths then produce secondary reactions that destroy more ozone, which increases UV penetration, which accelerates the cycle. And 3I-ATLS is pushing us toward that threshold. No, Marcus corrected. It already pushed us past it. Silence, again. Sterile. Final. At 8:42 a.m., another bulletin came in. This one flagged red level priority. Unexpected NO2 plume detected above South Pacific. Chemical signature inconsistent with known sources. Robert's face drained of color. NO2 that high up? He whispered. That only forms when something, NO2 in the stratosphere, at scale, means something is tearing apart ozone molecules faster than the planet can replace them. The UV spike wasn't a prediction anymore. It had begun. For the next 2 hours, the team worked feverishly, analyzing, recalibrating, arguing, running models so fast that the cooling fans in the consoles whined like engines overheating. Every few minutes, someone swore under their breath or whispered, "No, no, no," at a graph that refused to move in the right direction. But the worst moment came from an unexpected source. A junior technician, barely out of grad school, quiet, brilliant, unnoticed in the chaos, approached Marcus with a tablet in hand. "Dr. Hale," he said, voice shaking, "you need to see this." Marcus took the tablet. A satellite image. Gray, grainy, pixelated from transmission errors, but the shape at the center was unmistakable. A cone. A plume. Extending outward from 3I-ATLS, long, narrow, unnaturally straight. Not a dust tail, not a gas fan, a beam. "What's the wavelength?" Marcus asked, though he already knew. "UVC concentrated," the technician said, with periodic intensification matching the pulse cycle. This wasn't sublimation. This was emission. Directional. Coherent. Increasing. Someone whispered, "Why would a comet emit a focused ultraviolet beam?" No one answered. Because there was no answer that didn't break the rules of nature. Marcus zoomed in further. The beam wasn't perfectly straight. It oscillated, a subtle lateral vibration, like a needle searching for something. He checked the orientation.
The beam wasn't pointing at the sun, it wasn't pointing at Jupiter, it wasn't pointing directly at Earth, but it was pointing toward the plane of Earth's orbit, as if calibrating, as if aligning, as if waiting. "Everyone stop," Marcus said suddenly. The room froze. He walked to the center of the lab, placed the tablet on the table, and spoke slowly, not dramatically, not emotionally, but with the clarity of someone who has crossed the threshold from confusion to certainty. "This is not about what 3I ATLS is. It's about what it's doing." He tapped the tablet. "That is not a natural emission pattern. It's organized. It's structured. And it's interacting with Earth's atmosphere in a way that no known physical process accounts for." "So what's your conclusion?" Layla asked. Marcus looked at her. "That this object isn't passive. It's active." "Active how?" He hesitated. Then, "It's altering the environment it's entering." The room absorbed the statement like a blow to the chest. Layla shook her head slowly. "No natural body adjusts its emissions based on another planet's chemistry." Robert swallowed. "Then it might not be natural."
The words hung in the air, radioactive. They didn't say artificial. They didn't say constructed. They didn't say technology. But the echoes were there. Marcus held up a hand. "We're not making that claim." "But you're not dismissing it," Layla said. "No," Marcus admitted. "I'm not." Because the data didn't allow him to. At 11:03 a.m., they received the alert that confirmed everything. Early stage ozone thinning detected above southern Argentina. Rate of change inconsistent with solar activity or anthropogenic factors. Layla zoomed in on the readings. "It's following the pulse," she whispered. "Every time the emission peaks, ozone drops." "Magnitude?" Marcus asked. She typed, ran the differential, went pale. 17% loss in 6 hours. That number should not exist, not on a planet with a living biosphere. The ozone layer is robust, slow to form, slow to break, slow to change in any direction. Except now. "Is this local or global?" someone asked. Layla didn't answer, because the pattern was clear. It wasn't local. It was migratory, a wave. Moving west, moving fast, moving along atmospheric currents the same way a wildfire follows wind. In 4 hours, it would reach Chile. In 8 hours, Australia. In 12 hours, the Pacific. If the cycle continued, and all evidence said it would wrap around the hemisphere like a spiral. A spiral with a center. 3IAT Atlas. "Get the orbital reconstruction," Marcus said, "the full trajectory." Robert pulled it up. The file populated with lines, vectors, past positions, future predictions. Marcus stared at it, then frowned. "Where's the Jupiter perturbation?" he asked. "What perturbation?" Robert said. "The gravitational deflection. The close pass last month, it should have altered the trajectory." Robert zoomed in. "No measurable deflection," he said softly. "None." "That's impossible," Layla said. "Nothing passes Jupiter without—" "It didn't pass Jupiter," Marcus whispered. Everyone turned to him. "What do you mean?" Layla asked. Marcus pointed at a small notation on the reconstructed path, a subtle curve so slight it looked like noise. "This isn't a deflection. It's a correction." "A correction?" Robert repeated. "Yes," Marcus said. "The object adjusted its trajectory, actively, precisely, to maintain a predictable distance from Jupiter's magnetosphere." "That's not how comets behave," someone said. "No," Marcus replied. "It's how spacecraft behave." A cold, absolute silence filled the lab. One of the technicians stepped back from her station, as if distance could make the data less real. "That's why the probability of a natural Jupiter pass was so low, because it wasn't random," Marcus continued, voice steady.
The screen reflected in his eyes the curve, the adjustment, the stable path. 3IAT Atlas hadn't fallen into that orbit, it had chosen it. A soft alarm chimed from the central console. Robert checked it. UV index at ground level in southern Chile just spiked, 3 standard deviations above predicted. Ground level? Layla said. That shouldn't be possible yet. It is, Robert answered. The room suddenly felt colder. Ozone collapse wasn't theoretical anymore. It had begun on the surface. Marcus turned to the team. We need to inform every atmospheric lab, every observatory, every modeling center. The intercom cut him off. Dr. Hale, this is admittance security. A federal delegation has arrived. They're requesting immediate access. Everyone in the room exchanged looks. Did anyone call for a delegation? Marcus asked. No one had. The intercom clicked again. Dr. Hale, they're heading to your lab now. Footsteps echoed in the hallway, heavy, purposeful, not hurried, not hesitant. Marcus looked toward the door. And for the first time since the anomalies began, he felt something more than fear. He felt dread. The kind of dread that doesn't come from not understanding what's happening. The kind that comes from understanding exactly what happens next. The footsteps stopped outside the door. A brief pause. A knock. Polite, almost gentle. Then a voice. Dr. Hillel, we're here to take temporary custodianship of your data. Temporary. The most permanent word a government official could ever use. Layla stepped forward. On whose authority? The woman didn't even turn her head. Federal Interagency Atmospheric Risk Command, as effective as of 900 this morning. That doesn't exist, Robert said. It does now. She placed a folder on the nearest table. A thick one, heavy enough that when it landed, the thud sounded final. Marcus opened it. Inside were signatures, real ones, handwritten, and near the bottom, a seal he recognized instantly. Not NASA, not NOAA, not the National Security Council. The Department of Energy. That alone chilled him. DOE didn't get involved in atmospheric emergencies unless someone believed the threat was systemic, large-scale, planet-altering. The woman looked directly at Marcus. You are to cease modeling work and analysis until further instruction. All data will be encrypted and transferred to a secure federal server. The team erupted. You can't do that. This is a global emergency. People need this information. We're just supposed to stop helping? The woman didn't blink. No one is stopping you from helping, she said. We are simply reorganizing the effort. Reorganizing, Layla repeated quietly. Or uncontrolled. She ignored her. We appreciate your contributions, truly, but this situation requires coordinated messaging. Messaging. The word hit like a punch. They weren't here for science. They were here for silence. The next 30 minutes felt like a slow suffocation. Federal technicians entered, polite but efficient, disconnecting servers, cloning drives, tagging equipment with barcode stickers. Screens went dark one by one, like lights in a building shutting down during an evacuation. A man in a gray suit approached Robert. We'll need your access badge. He hesitated. Why? Your clearance is being updated, he said. Your previous one is no longer valid. Updated to what? The man didn't answer. He simply held out his hand. Robert looked at Marcus. Marcus looked away. He couldn't protect them from this. One by one, the team surrendered their badges, their terminals, their authority. Years of work reduced to a quiet room full of unplugged machines.
It wasn't hostile. It wasn't aggressive. It was worse. It was orderly, as if the script had been written long before 3IATS ever appeared in the sky. By noon, the federal team had taken control of the lab. The researchers were told to remain on site for possible reassignment. Food was brought in, Doors were locked but not visibly guarded, a subtle form of captivity. Outside the building, black SUVs lined the curb. Inside, the air smelled of cardboard, printer ink, and fear. Marcus sat alone in the break room, staring at a paper cup of untouched coffee. The woman from the federal delegation entered quietly and took the seat opposite him. "Dr. Hale," she said, "we're not your enemy." He didn't look at her. "Then what are you?" "People trying to prevent panic." Marcus finally lifted his eyes. "Panic is a reasonable response." "Not when it disrupts containment." "Containment of what?" Marcus asked. "The truth?" She folded her hands. "The situation is still evolving. That's why people need information," he said. "That's why people need stability," she countered. Marcus leaned forward. "Let me explain something," he said, voice steady but low. "We are watching the ozone layer fail in real time. We are watching UV radiation accelerate beyond modeled limits. We are seeing an interstellar object emit coherent ultraviolet beams synchronized with Earth's atmospheric chemistry. Stability is gone. Facts are all we have left." The woman didn't respond immediately. When she did, her voice was softer. "You think transparency will save people? I think hiding this will doom them." "No, acting on incomplete information will." She stood. "You're not being silenced, Dr. Hale. You're being protected from making a mistake with global consequences." Marcus didn't call her a liar. He didn't need to. She knew he knew. In the main lab, Layla had barricaded herself behind a workstation she managed to keep connected before federal technicians noticed. She waved Marcus over. "I mirrored the data before they locked us out," she whispered. "Not everything, but enough." "How much?" "Enough to know the ozone collapse is accelerating faster than they're admitting." She pulled up a graph, jagged lines descending at an angle too steep to be natural. "This is from ground sensors in Tierra del Fuego," she said. "UV levels are reaching the surface every time ATS pulses." "Daytime only?" She shook her head. "Night too." "That shouldn't be possible. Not without partial transparency in upper layers of the atmosphere. The collapse isn't hemispheric, it's target patterned." Marcus felt a chill crawl up his spine. "Show me." She zoomed out the map. Red zones blossomed across the southern hemisphere like spreading wounds, circular, elliptical, shaped by wind yet too regular to be random. "What's the centroid?" Marcus asked. Layla didn't answer. She didn't have to. It was already marked, a blinking dot in open ocean, directly under the projection line of the ultraviolet beam from 3I ATS. Marcus froze. "It's tracking the beam," he whispered. "It's worse," she said. "The beam is following atmospheric weaknesses, spots where ozone density is naturally lower." "Why?" "To widen them." The implication hit both of them at once. 3I ATS wasn't just emitting UV. It was probing, testing, searching for weak points, and exploiting them. At 2:50 p.m., a low rumble shook the lab. Distant thunder, though the sky outside was perfectly clear. A minute later, alarms blared from the emergency broadcast system. "Seismic event detected in the South Pacific," Robert yelled, rushing back into the room. "Magnitude 5.3, origin depth too shallow for tectonic cause." "What does that mean?" someone asked. "It means it wasn't an earthquake." Another alert flashed onto the screens, one of the few still hooked to external feeds. "Unidentified atmospheric flash detected above coordinates 39.7 degrees south, 123.2 degrees west. UV intensity briefly saturated satellite sensors." Marcus's throat tightened. A UV flash that strong, that focused, that directional. "What happened?" Layla whispered.
The answer came faster than anyone expected. A new alert. Stratospheric rupture event confirmed. 2 words dropped to the floor from under the entire room. Rupture event. Not thinning, not depletion. Breakage. Marcus felt like the air vanished. "How big?" he asked. No one answered because everyone could see the map. A hole had opened in the ozone layer. Not a patch, not a thinning region, a hole. 800 miles across and widening. Widening fast. Robert's voice shook. "The drop rate is unprecedented. None of this matches natural photochemistry." "It matches a pattern," Layla said quietly. "What pattern?" "A targeting pattern." Before the team could say anything else, the federal woman re-entered the lab. "Everyone step away from the terminals," she said. No one moved. Marcus turned to her. "Why wasn't this in your briefing? Did you know the rupture was coming?" Her expression was unchanged. "We knew a destabilization event was possible." "Possible?" Marcus shouted. "It's happening." She didn't flinch. "You are all being relocated," she said calmly. "There is a secure site in Nevada equipped for high-clearance atmospheric analysis. Your expertise is needed, but not here." "This is our lab," Layla said. "No," she replied. "This is now federal property." "And the data?" Marcus asked. "Classified." He stepped toward her. "You're not protecting the public. You're hiding from them." The woman looked at him, truly looked, for the first time. "We are protecting global order," she said. "If the world learns that an interstellar object is deliberately compromising the ozone layer, you will not have panic, you will have collapse." Marcus shook his head. "People deserve the truth. People deserve survival. And how do we survive this?" he demanded. The woman didn't answer, not because she was unwilling, but because she didn't know. The escort team began ushering researchers toward the exit. Some resisted, some argued, some cried, but all were moved. When they reached the hallway, Marcus felt his phone buzz in his pocket. He froze. Phones weren't supposed to be active. The federal team had disabled the internal network hours ago. He slid the device out slowly, shielding the screen. One new message. No sender ID. No timestamp. Just 6 words. "Checked the internal structure. Now." Marcus's pulse kicked. He turned sharply. "I need to retrieve 1 file from my terminal." The federal lead blocked him. "That's not permitted." "It's a calibration file," he lied. "Without it, the Nevada team won't be able to continue our analysis." She hesitated. For a second, doubt flickered across her face. Then she nodded once. "2 minutes. I'll accompany you." Marcus re-entered the lab with her shadowing his steps. He moved quickly to the station Layla had kept online and pulled up the deep penetration radar composites, the ones that showed the internal density map of 3I ATS. "Why are we looking at this?" the woman asked. Marcus zoomed into the core and stopped breathing. The density map wasn't random, it wasn't fractured, it wasn't geological. It was geometric, a perfect shell, surrounding a hollow interior, with radial supports evenly spaced like ribs. The woman leaned in. What is that?" Marcus didn't answer. He isolated the central region. The hollow chamber wasn't empty. It contained a structure, 24 meters across, spherical, smooth, symmetric, too uniform to be nature. The woman whispered, That's impossible." Marcus felt a tremor run through him. Not fear, not shock, but revelation. 3I ATS isn't a comet, he said. The woman swallowed. "Then what is it?" Marcus zoomed further. He highlighted the faint lines radiating outward from the inner sphere, conduits, channels, pathways. "An emitter," he said. "The pulsing isn't sublimation, it's energy cycling." The woman took a step back. "You're telling me this thing was built?"
I'm telling you, it's functioning." She stared at the screen, lips parted, but breath shallow. "Does the government know?" he asked. Her silence was answer enough. They knew, they'd known. Maybe not the details, not the structure, but enough to take control before any civilian team put the pieces together. Marcus turned the screen off. "What happens now?" he asked. She looked at him slowly. "Now?" she said.
We pray the internal mechanism doesn't increase output. It already is, he said. The woman closed her eyes. Then we're out of time. They were escorted to the waiting vehicles, black SUVs humming quietly in the cold afternoon air. The team watched their lab disappear behind tinted glass as the convoy pulled away. No talking, no theories, just the heavy silence of people who know the world has fundamentally changed. 15 minutes into the drive, Layla leaned forward from the back seat. "Marcus," she whispered, "did you get the message too?" He stiffened. "Message?" She nodded. "Check the internal structure." Marcus swallowed. "Who sent it?" he asked. Layla stared ahead. "I think," she said carefully, "it came from someone inside their own agency." "Why?" She finally turned toward him. "Because they're scared too." The convoy crossed the state line by dusk. The sun burned low, too bright, too sharp, like the atmosphere was already thinning. As they descended into Nevada, the radios crackled with emergency broadcasts. Unprecedented UV readings over the Southern Ocean. A second rupture zone has opened. Australian authorities reporting sudden spikes in... The static swallowed the rest. Robert stared out the window. "How long do we have?" he asked quietly. Marcus didn't answer. Because the light outside didn't look like evening light. It looked raw, unfiltered, wrong. The first sign, the first hint, the first touch of a world without ozone. And 3I Atlas hadn't even reached perihelion yet. The worst was still coming. The beam was still aligning, and the mechanism inside the object was still warming up. As the convoy approached the isolated federal complex rising in the desert, Marcus felt a truth settle heavily inside him. The fracture wasn't the ozone. The fracture wasn't the atmosphere. The fracture was us. The moment humanity learned something out there was not only watching our planet, but adjusting itself to it. The SUV rolled to a stop. Armed guards approached. The desert wind carried the faint smell of ozone. Metallic, sharp, unnatural. Layla whispered, "Marcus, look at the sky." He did, and saw a faint, pale streak, a line across the twilight, a line that wasn't a contrail, wasn't a cloud, wasn't natural. A line pointing directly from the horizon toward a place far above it, toward the incoming interstellar object, toward 3I Atlas. The beam had reached visibility, even to the naked eye. Marcus exhaled slowly. The woman in the suit spoke from the front seat. "Welcome," she said, "to the containment facility." But Marcus wasn't listening, because in that moment he understood something the simulations hadn't shown, something the federal agencies hadn't said, something the ozone data hadn't made clear. 3I Atlas wasn't just interacting with Earth. It was preparing Earth. For what? That answer was waiting inside the object, inside the sphere, inside the mechanism that pulsed like a heartbeat, echoing across the solar system. And whatever came next, it would not wait long. There's a moment every scientist dreads, not the moment you're wrong. Being wrong is easy. You correct, you revise, you publish again. No, the real nightmare is the moment the data is right and you wish it weren't. When the numbers stare back at you with the cold precision of something that doesn't care what it destroys. For the atmospheric team in Boulder, that moment came just after 3:14 a.m. By then, the lab was running on vending machine coffee and adrenaline. They weren't searching for doomsday.
They were doing what atmospheric scientists always do, reconciling satellite readings, checking calibration drift, updating seasonal stratopause models. And then the UV index line snapped upward, not by tenths, not by noise, by whole integer units. A jump that should take years, not hours. At the same time, something else appeared, a thinning band in the ozone layer over the South Pacific, subtle like a bruise forming under skin, but in the time-lapse playback it spread with unnatural symmetry, widening, deepening, behaving like chemistry under pressure rather than natural depletion. Nobody said the word atlas yet, but everyone thought it. Dr. Karen Roslin was the first to speak. "It's not catalytic chlorine," she murmured, staring at the spectral curve as if it would apologize. "And it's not Nox intrusion. This shape shouldn't exist." Someone behind her whispered, "Check the timestamp." "It's correct," she said. "I already checked." Silence sat heavy in the room, and underneath it, the unspoken truth. The anomaly lined up too closely with 3I Atlas's solar approach. The comet that shouldn't pulse, the jets that shouldn't align, the UV curve that shouldn't rise. No one wanted to draw the line between them. Not yet. Not until the next dataset arrived. And when it did, the line drew itself. At 4:06 a.m., the Boston Atmospheric Monitoring Array reported a 2.4% global ozone deviation. At 4:11, the number updated to 3.7%. By 4:19, it hit 5.2%. Karen froze when she saw that one. A 5% global drop in ozone layer isn't a statistic. It's a warning. It means UV radiation at ground level increases enough to sterilize small ecosystems. It means plankton stress, coral bleaching, agricultural failure zones expanding like cracks in a windshield. That's at 5%. The team in Boulder calculated the trend line. If the curve continued, if the mechanism driving it remained stable, the ozone layer could reach 39% degradation within months. But the thing that made Karen's hands go cold wasn't the magnitude. It was the periodicity. Every spike, every dip, every oscillation in atmospheric chemistry matched the 16.16-hour pulse of 3I Atlas. No model could explain that. No natural mechanism synced atmospheric chemistry with a comet's breathing cycle. Unless it wasn't natural. Unless 3I Atlas was doing something to the upper atmosphere. Something resonant, rhythmic, cumulative. Karen felt her breath turn shallow. "Oh my God, the pulses," she said barely above a whisper. "They're not optical, they're radiative." A younger researcher, Dennis, swallowed hard. Meaning, she said, Atlas isn't just brightening, it's emitting." The lab went still. By sunrise, the data reached NASA's Goddard Center. By noon, an emergency teleconference was underway. Boston, Boulder, Washington, Houston, JPL. Every screen in the network flickered with pale, worried faces. The question wasn't whether the anomaly was real. It was. The question was why. Dr. Malcolm Price, a calm man whose voice usually grounded the room, spoke first. "Before we jump to conclusions, we need to address the elephant in the room. Is there any known cometary mechanism capable of producing UV flux at this scale?" The answer came from a heliophysicist in Pasadena. No. High-energy UV emission requires temperatures comets don't reach, and even if they did, the intensity drop-off at distance would make it negligible when it reaches Earth. "So the source isn't thermal?" Price asked. "Not in any conventional sense." The phrase hung in the air like smoke. Karen leaned into her mic. "Then what explains the atmospheric chemical response? Because we're seeing synchronized variations, and the periodicity is exact, down to the minute." A man from JPL rubbed his forehead. "Could be coincidence." "No," Karen said, "it's clockwork." Someone else chimed in. "Could be instrumentation drift." "Cross-array data eliminates that." "Could be solar interference." "The sun's output is stable within margin." Slowly the room shifted from skepticism to fear. Because once you eliminate all natural processes, you're left with something you don't want to consider. Something that feels impossible. Something that feels engineered. Price ended the argument with one sentence. Let's assume the worst-case scenario. What happens at 39% ozone depletion? Karen closed her eyes before answering. UV radiation becomes a mass extinction driver. Part of the team refused to believe what they were seeing. They looked for errors. They hunted for glitches.
They combed through calibration logs, solar flux tables, atmospheric cross-sections, anything to explain the anomaly without invoking Atlas. But the deeper they dug, the clearer it became. The ozone wasn't collapsing uniformly. It was collapsing in rings. Expanding rings, spaced with geometric regularity, almost like wave fronts. The same pattern Atlas's coma exhibited when it pulsed. 16 hours bright, 16 hours dim. Each pulse sent something across interplanetary space. The numbers suggested high-frequency UV spikes or a cascade of charged particles, though the mechanism remained unknown. Whatever it was, it interacted with ozone molecules in a way that no comet, no natural body, no known astrophysical phenomenon should. Something that behaved like a system, not a random emitter. Something coherent. And then, as if to confirm their fear, the next pulse hit. The ozone layer rippled, the UV index spiked, the rings expanded, and the global average dropped another 2%. The call that night wasn't routine. The White House wanted answers. Karen and Malcolm Price were asked to brief the National Security Advisor, the Secretary of Energy, and several officials whose titles weren't introduced.
Karen walked them through the data, the periodic pulses, the synchronized atmospheric shifts, the projected 39% depletion curve. She didn't dramatize, she didn't speculate, she didn't mention intent or artificiality. She described the numbers exactly as they were, and let the numbers scare them. One of the officials leaned forward, voice low. Could this be an attack? No, Karen said quickly. There's no evidence of targeting, no directional modulation, no variation correlated with Earth's rotation. It behaves like a broadcast, not a weapon. So it's natural? Karen hesitated. I didn't say that. Then what are you saying? That we don't know. But you have hypotheses? Not ones I can responsibly present here. That answer shook the room more than any speculative theory could have, because uncertainty is always more terrifying than the truth. After the briefing, Karen stepped outside into the cold Washington air. She hadn't slept in 28 hours. Her eyes burned, her hands shook. But what haunted her wasn't exhaustion. It was the realization that they had crossed a threshold. Earth's climate system responds slowly. It has inertia. But the ozone layer is fragile. Once it thins past a certain point, feedback loops accelerate. UV penetrates deeper, breaking more ozone, which allows more UV through, which breaks more ozone. A self-reinforcing collapse, a runaway. And the pulses were pushing it toward that edge. She stared up at the faint glow of the sky. Somewhere far beyond it, too far to see, 3I-Atlas was breathing again. Another pulse, another ripple, another unseen wave racing toward them. She closed her eyes. How do we stop something that isn't aiming at us but still threatens everything? There was no answer. The next morning the teams convened again. New data had arrived. But this time the anomaly wasn't acceleration, it was dropout. For the first time in days, the ozone decline curve flattened. The UV index quieted. The rings softened. The pulse impact diminished. Dennis stared at the graph, baffled. It's slowing down. Why is it slowing down? Karen leaned forward, studying the numbers. This can't be right. But it is. The coupling effect is weakening. No, she said softly. It's shifting. What do you mean? It's moving to a different latitude band. And it was. The weakening wasn't recovery, it was redistribution. The ozone depletion ring wasn't shrinking, it was migrating, drifting toward the equator where solar flux was most strong. Her heart dropped. Oh no, she murmured. It's following insulation. Meaning whatever mechanism is interacting with our atmosphere is amplifying solar UV where the sunlight is already most intense. Dennis swallowed. So, the danger just moved? Exactly, she said. And we have no idea where it will focus next. By early afternoon, the shift locked into a new pattern. The depletion zone began forming a belt, equatorial, predictable, expanding westward in phase with planetary rotation. But the strangest part wasn't the pattern, it was the frequency. The belt pulsed. Every 16 hours, Malcolm Price stared at the dashboard. "This is impossible," he whispered. "Atmospheric chemistry doesn't oscillate like this." "Unless it's being driven," Karen said again. He looked at her. "By Atlas. By something associated with it. So the ozone layer is resonating with an interstellar object. That's one interpretation. What's the other?" She met his eyes. "We're not observing a cometary emission. We're observing a system." He blinked. A system? Something with internal rhythm, consistency, predictability. Something that doesn't just emit energy, it cycles. Malcolm sat back, breath unsteady. That sounds engineered. She didn't confirm it. She didn't deny it. She simply let the implication hang between them, heavy enough to warp the air. By evening, new evidence arrived not from satellites, but from the ground. Farmers across the equatorial line reported leaf scorch on crops that should tolerate sunlight. Coral monitoring stations reported abnormal bleaching patterns that didn't match sea surface temperature models. Wildlife rescue centers recorded cases of sudden UV-induced eye damage in animals. "Already?" Dennis whispered, when the reports were compiled. "It's already hitting ecosystems?" Karen rubbed her temples. UV change is immediate. Biology isn't buffered the way weather is. So, if the pulses intensify, life won't have time to adapt. He swallowed. "What does the model predict now?" She hesitated. 39% is no longer worst case. It's median. That night, Karen couldn't sleep. She sat in her hotel room staring at the wall, replaying every frame of the data in her mind. The rhythm, the consistency, the strange migratory behavior of the depletion rings. It didn't match a random emission. It didn't match natural resonance. It matched something else, a pattern she hadn't wanted to admit she recognized, until now. She grabbed her laptop, opened the Atlas Photometry Archive and overlaid the pulse coma expansion data with the ozone depletion timeline. The match was perfect. Too perfect. Not just in timing, in geometry. Atlas's pulses expanded in concentric shells, and those shells propagated outward through space, arriving at Earth as diffuse waves. But the ozone depletion wasn't random. It mirrored the shell arrival patterns. It reflected phase alignment. The atmosphere responded like a membrane hit with rhythmic pressure, oscillating at the imposed frequency. This wasn't just influence, it was synchronization. Her breath went thin. She whispered to herself, "Oh God, the atmosphere is entraining." meaning Earth's protective layer was being locked into the rhythm of Atlas's emissions, adopting its frequency, responding like a driven system, like an object being tuned. The realization hit her with nauseating force. Atlas wasn't just passing through, it was coupling with a planetary environment. Whether intentionally or not didn't matter. The effect was the same. Earth was being tuned, and nobody knew what happened when the resonance reached its peak. She closed her laptop and pressed a trembling hand to her forehead. "We're not dealing with a comet," she whispered. "We're dealing with a mechanism." Outside, the city lights glowed faintly through the window. Somewhere above them, beyond the haze, beyond the atmosphere now pulsing to an alien rhythm, Atlas exhaled again. Another pulse, another wave, another unseen tremor descending. Karen felt the vibration in her bones, not real, not physical, but psychological, like the echo of a countdown she hadn't realized had started. And for the first time since the anomaly began, she felt something worse than fear. She felt certainty. The ozone layer wasn't just declining, it was responding. And the next stage, whatever it was, would not be subtle. No one slept the night before perihelion. Not the atmospheric teams, not the heliophysicists, not the emergency governance councils, not the few hundred scientists scattered across the world who understood, or at least suspected, what the next 24 hours might bring. The ozone layer was no longer a shield. It was a driven membrane, vibrating, thinning, reshaping under the invisible rhythm of 3I-Atlas, a rhythm that was about to intensify. Because perihelion, the closest orbital approach to the Sun, wasn't just a point in space. It was a trigger, a catalytic moment, a test of whatever mechanism pulsed inside the interstellar object's hollow core. Until that day, uncertainty had only been their defense, a small, fragile hope that the correlations were coincidence, the resonance accidental, the timing unfortunate. But when the first pulse struck after dawn, that hope cracked. Because this one was different. It wasn't subtle. It wasn't spectral. It wasn't confined to orbital telemetry. It was visible. To the naked eye, at 6:22 a.m., tourists on a beach in Peru saw the sky flicker, a faint, ultraviolet shimmer like heat distortion, but too geometric, too synchronized, too patterned. What they didn't know, what no one on that shore could have known, was that sensors stationed in the upper stratosphere recorded the event as a UVC burst strong enough to disrupt calibration equipment. A UVC burst from millions of kilometers away. Impossible. Unnatural. Real. The ozone thickness over the equatorial band dropped another 1.8% in seconds. Seconds. Dr. Karen Roslin, running on 15 hours of coffee and fear, stared at the incoming numbers in disbelief. No natural emission spike could cross space this fast, she whispered. This isn't decay. This is modulation. Across the room, Dennis froze at his station. The atmosphere responded instantly, he said. There's no lag. None. That's impossible, Karen said. But the graph disagreed. Atlas pulsed, the atmosphere echoed. Pulse, echo. Pulse, echo. Like a heartbeat. But not Earth's. Earth now had two rhythms, and one of them belonged to something alien. By 7:40 a.m., the global ozone deficit had reached 21%. News outlets weren't reporting it, governments weren't confirming it, but satellites don't lie. The world was dimmer, sharper, bluer. The sky's color had shifted subtly, the way it does at altitude. Only this time, it happened everywhere. And then came the animals. Migratory birds altered their paths,
Marine mammals surfaced erratically, confused by the sudden light penetration. Insects vanished from fields they'd filled the day before. Biology was responding faster than humans could. At 8:15 a.m., Karen received the message that confirmed her worst fear. Ground-level UV estimates unacceptable for prolonged exposure. Unacceptable. Not dangerous, not elevated. Unacceptable. Meaning, unshielded human skin could blister in under an hour at equatorial latitudes. Meaning, ecosystems that evolved under stable UV flux were now being cooked. Meaning, 3I Atlas II was doing something no comet should do. "Pull the perihelion models," Karen said, her voice shaking. "All of them." Dennis pulled them up. The projected pulse intensity curve skyrocketed around perihelion, not doubling, not tripling, increasing tenfold. Karen's breath hitched. "No, that can't be right." "It's a probability-weighted model," Dennis said, "based on internal energy cycling inside the object. The more solar input it receives, the stronger the mechanism pulses back." "But that means—" He nodded. "At perihelion, the pulses won't be atmospheric disturbances." "What will they be?" she asked. "Events," he said. "Planet-wide events." At 9:03 a.m., Atlas brightened suddenly, a flare so intense that it briefly outshone every comet on record, even Hale-Bopp at peak. Ground-based observers saw nothing unusual. Space-based telescopes saw everything. A beam, not wide, not diffuse, but sharply defined, lanced out from the nucleus. It wasn't aimed at Earth. It wasn't aimed at the Sun. It was aimed at nothing obvious. But it pulsed. Once. Twice. 3 times. NASA's solar instruments detected a faint echo, the solar corona briefly dimming in a frequency band it had no chemical reason to interact with. "Is it altering the sun?" someone whispered during the emergency call. "No," Price said sternly. "Reflecting. The mechanism is interacting with radiation." Karen corrected him. "No, it's modulating it." He froze. "What do you mean?" "The beam is interacting with the sun's UV output like a tuning fork against a bell." "And Earth is the bell?" She didn't answer. She didn't have to. At 10:17 a.m., the second anomaly struck. This one hit the magnetic field. Not a magnetic storm, not a solar wind spike, a resonance. A 16-hour cycle superimposed onto the magnetosphere. It wasn't strong enough to cause immediate electrical disruption, but it was strong enough to distort satellite orbits by fractions of a millimeter. Fractions that were measurable. Fractions that were rhythmic. Atlas wasn't just interacting with the atmosphere, it was interacting with the planet. Meanwhile, the Federal Containment Facility in Nevada buzzed with feverish activity. The scientists relocated there, including Marcus Hale, worked in a sealed, windowless complex designed for classified atmospheric scenarios. Marcus hadn't seen natural daylight in 24 hours. He didn't miss it. The daylight outside wasn't the old daylight anymore. Inside the operations hall, the air vibrated with tension. "They're calling it a perihelion cascade," someone said. "A compound resonance between solar flux, Atlas emissions, and Earth's atmospheric chemistry." Marcus stared at the wall of screens. The ozone layer wasn't collapsing uniformly. It wasn't peeling like an orange. It wasn't breaking like ice. It was oscillating. Not thinning, not healing. Oscillating. Like a diaphragm under pressure. Every time Atlas pulsed, ozone density dipped. Every time Earth rotated under sunlight, it dipped again. The two rhythms were beginning to sync. A planetary entrainment. "The atmosphere isn't just responding," Marcus said. "It's cooperating." A technician frowned. "What does that mean?" "It means the ozone layer is behaving like a medium designed to carry the oscillation further." "Carry it where?" Marcus shut his eyes. "Into the biosphere." At noon, a new kind of report appeared. Not atmospheric, not orbital, not radiative, medical. People living at high altitudes in Peru, Bolivia, northern Chile reported sudden photokeratitis spikes, skin lesions, migraines triggered by ultraviolet photons penetrating deeper into tissue than before. Hospitals filled with patients who didn't understand why the morning sun felt like a welding torch. Karen read the reports, her pulse thudding in her ears. "This is early onset," she whispered. "Biology isn't supposed to react this fast." "It's not biology. It's exposure." She looked at him. "No," she said. "This looks like resonance damage." "Explain." "UV penetration depth has increased by almost 10 nanometers in some regions. That doesn't happen with simple ozone thinning. Something is altering the frequency distribution." "You're saying Atlas is changing the quality of sunlight?" She didn't answer, because she couldn't. There was no established vocabulary for what was happening. At 1:14 p.m., alarms blared across every monitoring system. The perihelion pulse began. The flare from Atlas expanded outward in a perfect geometric shell, spherical, uniform, coherent. A structure. Not a plume. Not a gas cloud. A structure. The same structure detected in its internal cavity. The shell expanded faster than light-scattering models predicted. Not accelerating, already fast, as if it had been standing still until released. Karen watched the solar telemetry spike. Marcus watched the ozone graphs plummet. There was no hiding it anymore. The 39% depletion threshold wasn't months away. It was hours. At 1:16 p.m., the Earth's atmosphere buckled. Not visibly, not catastrophically, but measurably. Sensors at 30 kilometers altitude showed pressure disturbances like ripples in water, concentric waves flowing outward from equatorial latitudes. "These are shock fronts," Dennis said, horror seeping into his voice. "UV-driven shock fronts." "No," Karen whispered. "They're not just UV, they're structured." The waves had spacing, depth, predictability, like something was imprinting a pattern onto the sky. "What is Atlas doing?" Dennis asked. She shook her head slowly. "She's not doing anything new," she said. "It's doing what it always does. We're just now sensitive enough to see the full effect." He stared at her. "Then why is the collapse accelerating?" "Because Earth is reaching the resonance point." By 2 p.m., the world outside had changed. Light felt thinner, colors washed out, shadows sharpened. In some regions, the sky took on a faint violet tint, the color of a battered ozone layer bleeding wavelengths that never should. Animals hid. Children cried when they stepped outside. Airliners altered routes as UV sensors on their fuselages hit red zone warnings. Governments issued cautious advisories. But the data kept pouring in, and the news was worse. The collapse wasn't just ozone. The collapse was temperature inversion in the upper stratosphere, a reversal of the thermal gradient caused by unnatural UV heating, something the planet wasn't designed to withstand. Marcus stared at the inversion graph. "This is the threshold." "The threshold for what?" an analyst asked. "For atmospheric instabilities we can't predict." "Such as what?"
He looked at her, eyes hollow. "Everything." At 2:40 p.m., the second perihelion pulse hit. This one wasn't like the first. The first had been energy. The second was information. Telecommunications systems recorded a faint oscillation, a low-frequency modulation embedded inside the ultraviolet spike. Not a message, not a signal, a pattern, geometric, repeating, mathematically perfect. It resembled the internal lattice of Atlas's spherical cavity, as if the object's emissions were echoing its structure, as if the pulses weren't random, as if they were instructions. Karen stared at the modulation printout, heartbeat stumbling. It's a carrier wave, she whispered. Atlas is sending structural data. To where? Dennis asked. She swallowed. To anything capable of receiving it. Earth. No, not Earth. Then what? She looked at the timestamp, at the atmospheric ripple, at the ozone response, at the magnetic shift. It's transmitting to the medium itself, the atmosphere. At 3:12 p.m., the final pulse began, the strongest ever recorded in human history. It arrived not as a flare, but as a silence in the instruments, a blank, a void. For 12 seconds, every UV sensor saturated simultaneously, as if the world had been submerged in invisible lightning. When the instruments recovered, the numbers were beyond catastrophic. The global ozone deficit was now 34% and falling by the minute. The upper stratosphere was destabilizing. The equatorial belt was fragmenting. Shock waves raced through the atmosphere like thunder with no sound. Karen whispered, "This is it. This is the cascade." Marcus read the models 6 states away and felt the same dread. This isn't decay. This is transition. Transition into what? A technician asked. Marcus didn't answer. Because the model didn't say. Because the planet had entered a state no model accounted for. The ozone layer, Earth's protective crown, billions of years in the making, had become a canvas. A canvas something alien was painting on. At 4:03 p.m., the final anomaly appeared. It wasn't in the atmosphere. It wasn't in the magnetic field. It wasn't in the radiation levels. It was in space. The spherical shell emitted by Atlas, the perihelion wave, hit Earth's exosphere and changed direction. Not deflected, not scattered, redirected. As if it had encountered something it recognized. The shell aligned itself around the planet, faint, invisible to ordinary light, but perfectly geometric in ultraviolet. An envelope, a boundary, a cage. Karen stared at the formation, breath trembling. It's enclosing us. Dennis shook his head furiously. Why? Why would it? And then he stopped. Because one possibility, the one they all refused to entertain, hovered between them. What if Atlas wasn't reacting to Earth? Karen said softly. What if Earth was reacting to Atlas? He swallowed. Meaning? She looked at the timestamp, at the atmospheric ripple, at the ozone response, at the magnetic shift. It's transmitting to the medium itself, the atmosphere. At 4:20 p.m., the shell fully enclosed the planet. The atmosphere dimmed, the sunlight warped, the sky shimmered faintly violet. The ozone layer reached 39% global depletion, the number predicted in the very first catastrophic model. But it didn't stop. Not yet. The oscillations intensified, the air vibrated, and for one terrible moment, the entire atmosphere behaved like a single resonant object, ringing with a tone no ear could hear, a global harmonic. And then, silence. The ozone decline curve flattened. The UV index stabilized. The shock fronts dissipated. The atmosphere exhaled and held. Karen stared at the graph, speechless. Dennis whispered, It stopped." She nodded slowly. "Why?" "I don't know." They watched, breathless. No new spikes, no new dips, no more pulses. Atlas had reached perihelion. It had done what it came to do. And now, it was quiet. But in that quiet, something remained. The spherical resonance shell. Faint, stable, encircling the planet like a second invisible atmosphere. A structure not made by humans, not made by nature, not meant for harm, but clearly meant for something. Karen whispered the only thought she could form. We weren't the target. Dennis swallowed. Then what was? She closed her eyes. I think, she said softly, the atmosphere was. Nobody celebrated. Nobody relaxed. Nobody understood what would come next. The ozone layer was broken but stable. Atlas was intact but silent. The resonance sphere was present but inert. A global, alien-made shell surrounding Earth. Scientists had no name for it. Governments had no policy for it. Humanity had no precedent for it. The final data of the day was transmitted to every high-clearance lab. A simple, terrifying sentence. Atmospheric resonance complete. Unknown function. Karen stared at the screen until her eyes burned. Marcus stared at the same message in Nevada. Every scientist staring at it felt the same thought crawl through their mind. Whatever Atlas started today, it wasn't finished. Not by a long shot. And somewhere above, in the twilight sky, something faint shimmered across the horizon. A ripple in the invisible shell. A countdown. A signal. A beginning.